All right. Good morning. Wow, that's actually a decent amount of energy for 9 a.m. I was actually going to ask you guys to get up and do calisthenics and jumping jacks and shit, but I think you'll be fine. So, my name's John Sheehan. I'm an architect in the Windows team on the application experiences team. For Windows 8, I've mainly focused on the application model that we built, the new one for Metro-style applications. I've been at Microsoft a little over 5 years. I came to Microsoft through the acquisition of Softricity. I always love asking this question: is how many people knew SoftGrid, the product? Actually, a decent amount in this room. How many people know AppV, the Microsoft AppV? More. Softricity was acquired, and SoftGrid became AppV. And so I was architect for AppV for about 3+ years at Microsoft, and chief architect for Softricity for, I don't know, a bunch of years before that. And then I came over to the Windows team for Windows 8. And I can honestly say I'm having more fun now than I ever have in my career. And I've had a lot of fun in my career. Early in my career, I got to build vision systems, which for software people, like actually building hardware and having a physical thing happen that then caused software to happen and get to tie them all together. That's a lot of fun. But actually what I do now is even more fun. So today we're going to talk about app data roaming. This is supposed to be a chalk talk, which means I have 2 slides. It's going to talk for about 5 to 10 minutes and then do questions. But it turns out most of you didn't come to my session on this topic, so I'll talk a little bit longer. But we can probably just go into questions and cover most of the same material. So first, let me talk about app data. And since you didn't come to the session, I guess I should probably start by defining app data. App data is the information and data that is associated with your application that, you can think about it this way. If the user uninstalled your app, and that data went away, they'd be fine with that. It's the preferences. It's any files you cached locally to make performance better or to work offline. Like, that's app data. It's not user data. So user data are things like pictures of your children, videos of your birthday. Like, that's user data. And that kind of stuff we're not talking about here. There are other sessions on libraries and our file APIs that will teach you how to deal with user data. The one thing I will ask is, when you're writing your app, don't use these APIs to store user data. Because if you're using these APIs and your app gets uninstalled, all of that stuff vanishes. It gets deleted. We clean up. And we do it automatically so that you as a developer don't have to become an installation developer as well as a developer for cool apps. So we have one place in the WinRT namespace that you go to deal with all of your app data needs. It's windows.storage.application data. This object is the starting point for getting at all of the features that we support for app data. There are local areas of it where you have local settings, you have local files. There are roaming sections of it where you can store roaming settings and roaming files. I encourage you to watch the video from my Wednesday session, which they changed the title 12 times, and it was something like creating continuous experiences for your users across devices or something. I don't know, something like that. Go find that talk and watch it, and you'll get a much deeper background of all of the different pieces of this. Here, I'm going to drill down a little bit more, a little deeper than I did on Wednesday, and talk about how some of the more advanced features work. I'm going to talk a little bit about the roaming stuff, and then I'm just going to open it to questions. So the application data object underneath the covers has basically 5 areas that you can explore. There's a local folder, That's obviously where you store all your local files. Local means specific to this system. Those files will remain with that system until the app is uninstalled. There's a temp folder, which is kind of like you think. We create a temporary directory just for your app. Those files will not automatically get cleaned up, so you need to be careful about assuming that you put something in temp and you never have to think about it again. If you put tons and tons and tons of files in temp, you will use up hard disk space. If the user does use the disk cleanup wizard and says clean up temp files, then those things will get cleaned up. So you do need to be aware that if you store it there, you need to be careful, but at the same time, you need to understand they may disappear from underneath you. There's a roaming folder, and the roaming folder is where you would put any files that you want to roam. In a minute, I'll talk about the limitations, intentional limitations that we put into to roaming around data size. But for now, you can think about it as if you have some data, you store it in a file, you want it to go to every machine that the user is using your app on, that's where you put it. There's also two areas that deal with settings. Settings are name-value pairs. They're typed, right? So any of the basic types that we have in WinRT, like string and int16 and int32, all of those types are supported if you want to store things as a setting. We don't support storing like entire objects, like you can't take some dynamic object that you nude and stick it in a setting. It won't work. You'll get an exception saying that it's an invalid type. But all of our base types we support as settings. Settings should only be used for user preferences. I've been saying this a lot, and I just want to make sure that it sinks in, that we didn't design it to be some like database. Like you shouldn't be storing thousands of things in there. It's a small number of things. We made it so as to give you a convenient way to get high-speed access to this data. If you have larger amounts of information, we want you to store them in files. It's just the right place to put things, is in either the local or roaming folder, is where you should be storing that kind of information. So let's say, for example, you have the user filling out a form, and you want to store that information away in case you get shut down or something, your app gets terminated. That could be a bunch of information. That's not a setting, right? A setting is if I go into your preferences pane and I flip some toggles and I hit some checkboxes or something, that's a setting. And so make sure that you differentiate between the two. Sure. Settings can roam. There's local settings and there are roaming settings. So again, the talk goes into a lot more detail about this. But if you think about it this way, you will have some settings that are really specific to that PC. So I always use as an example, like let's say you build a video streaming app. Like you want to stream videos. And you let the user choose whether they want like very high quality or medium quality or low quality. Like that setting probably shouldn't roam because on my PC at home, I might be connected to my my cable modem, and I'm like, yeah, I always want the high speed. It's fast. I'm never going to pay per byte, so it's not a metered network. Yeah, I want highest quality you can give me. But then if I have like a tablet PC and I'm walking around with it and it's 3G, I probably would maybe set that to low so that the video starts streaming quicker and I don't use too much bandwidth because eventually it's probably going to be metered. And so that's an example of like a local setting. Roaming settings are the things that like once you set them once, you really want them to be everywhere. When you're defining, as a user, you're setting up your experience as an application, you want to do that one time and just have it be everywhere. So the example I usually use is think of like a mail client. Like every time I install Outlook and I launch it for the first time, I immediately have to go in and say, oh, my signature. My signature doesn't change depending upon which PC I'm on. I always use the same signature. I will set up the fact that I like the left-hand pane to be the folder view, not the mail view. I make sure that the reading pane's on the right. I get it set up, and that's my experience for mail. That's a great thing to roam because that means I'll set it up one time and I never have to do it again. You know, I buy a new PC, or you know, I even potentially go to a friend's house and log into their PC. Whatever I do, as long as I'm logged in with my Microsoft account, those settings will roam to me, and I can use them, and I don't have to touch anything. And so that's really the difference in experience. On Wednesday, I talked a lot about also there are opportunities to roam the user's experience beyond just preferences and settings. I created a demo app that is a video streaming client. And the roaming experience that I showed was, hey, I'm watching a video. And I'm halfway through it, and you know, I'm on my PC at home, and I'm going to run to the coffee shop. So I hit pause in the video, I grab my tablet, I go to the coffee shop, I sit down, put in my headphones, I launch the app, and it's on the exact video that I was at my house, at exactly the same time I was at my house, and now I can just continue watching it. And it's a really nice experience. And so this is the opportunity that you have with Windows 8, is you can very easily create that experience. And I should probably jump into some code for a second because, like I said, I really didn't expect to talk much today. But I just want to show you the code for that video app and show you what it takes to get something roaming. So where is it? If I come down here, for my app, I had a preference for the user. To make that preference roam to every system and always have it always be available, it's one line of code. That's the whole thing. That's it. All I do is I say, hey, I have my app data object. I go into the roaming settings section, and I go to the values. And the reason that we have values is actually settings can be hierarchical. You can create like subcontainers of settings if you want to have a little more structure to your settings. And so go into the roaming settings. By the way, this particular setting is rather poorly named because it's named roaming settings. Let's pretend it was called Fred. And I just set Fred to whatever value it has to be. And at that point, every machine that I go to, it will have that same value. And if there are conflicts, if the value gets changed on two different systems, it'll automatically do the conflict resolution and pick the latest one by time. I also had an example here of a local setting. And so one thing that this app can do is it can automatically cache the video you're watching, like it can download it behind the scenes while you're watching it, so that if you lose connectivity, you don't even know, it just keeps playing. Nice feature. I may or may not want to use it if I have 3G. I may decide I really want it for 3G because that network's flaky. Or I may say, videos are big, and eventually I don't have an unlimited data plan, so maybe I don't want to do it. So it's an example of a local setting. Yet again, one line of code. All right, so now we really want to talk about roaming. That was really sort of the thing that we wanted to focus in on in this talk. In Windows 8, we have built a great roaming infrastructure for you. You're welcome. All of the things that it takes to successfully roam data, we took care of. And so it's stuff that if you were going to build your own solution, you probably wouldn't have even thought of. And actually, when we started the project, we didn't really think of. Like, we sort of started writing specs and figuring out what were all the edge conditions. And it's things like making sure that if you're in the middle of syncing to the cloud and like you lose connectivity, you don't want half the data to be up there. And so you have to do it in such a way that you never corrupt the state in the cloud, because if you corrupt the state in the cloud, you're done, right? The data up in the cloud, you have to be very, very careful with. It's about making sure that you use the minimal amount of bandwidth you can. So if the user or if the app changes a file, and the file's rather large, making sure that you only sync the pieces that changed. It's dealing with connectivity changes. When I'm using your app, I might not even be connected to the network. It may not have a connection to the cloud. And so if you tried to build the sync infrastructure yourself, well, you wouldn't be able to sync at that point. And you'd have to hope that one of the times the user launched your app, you'd be able to sync. But the Windows 8 sync infrastructure is running all the time in the background. It's a system service. It's something that the system just provides for you, and it provides for all of the apps that are running. And it can sit there and wait and say, okay, I know there are all these changes across lots of apps. I can wait, and when I see connectivity come back, regardless of which app is running, I can now, behind the scenes, sync it up to the cloud. Other things we have to think about are things like the user may be browsing at the same time. They may be watching a video. They may be using the network a lot. And we wouldn't want the syncing that's happening behind the scenes to cause the video to get choppy and stuff because we're blasting stuff up to the cloud or we're downloading changes from the cloud. And so we have to be careful to make sure that we're friendly or nice with the user's bandwidth. There's lots of other stuff that goes on there too. So the way that the roaming stuff works is you're just going to go ahead and make that one line of code call for a setting, or you will write to a file in the roaming folder. You'll just do a write operation. Under the covers, the OS detects that some data that's supposed to roam has changed, and it effectively sets up a job behind the scenes that says, there's now information that I have to get from this PC into the cloud. We have sort of a debounce period there that says, okay, if they just change one piece of data, it's probably likely a few more may change. So we don't want to start syncing that right away because there may be 20 milliseconds later another change and another change and another change. So it's effectively about a 10-second, right now it's about a 10-second debounce period. That's a policy thing that we may tune before we ship. But right now it's around 10 seconds. And we say, okay, we noticed a change. Wait about 10 seconds. And then we can go ahead and do a sync to the cloud. And then if another change comes in, we'll have another debounce period. The goal was not to make like real time, like you make a change and immediately goes to the cloud kind of system. Because the usages that we have for it and the scenarios that we expect to use it for don't require that. Right? It's really about being able to have a user have a continuous experience across all their PCs. And it's about small amounts of data that really are preferences and being able to have one nice flow and one nice experience across all these devices. At this point, I think I'm probably just going to break into questions. So there's two options for questions. Oh, and by the way, so there's a whole bunch of related sessions that you can go and see. There are SkyDrive APIs. So you may have scenarios that this doesn't work for. So for example, if I look at the roaming, right now we put a limit of 30K on the data that from the app data folder that will roam. And almost without fail, the reaction that people have is, that's tiny. Like, why is it so small? Can't you give us like a meg, 10 megs, 100 megs? You know, like, that seems more reasonable. And the answer is, for the scenarios and what we want you to use it for, we really don't want you to do that. Usually, people will say, well, great. So if I am writing a social networking app and the status updates come down, I want to cache those so that if the user doesn't have connectivity, they can launch the app and they'll still see them. And I said, great. They said, and I want that to roam. I said, not great. Why? Because in order for that that's just cache data. The real data is already in the cloud. In order for that to get over to the other machine's going to have connectivity anyway. So you're much better off saying, you know, that's something I can easily just fetch from the cloud. I'll build my app that way. And your users aren't going to have an odd experience for that. It's not going to be like, you know, hey, I was looking at tweets over there, and that was connected, and this one isn't connected to the network right now, and yet I'd still expect to see that same data. Like, it's not going to happen. The other thing that people start talking about is, you know, like pictures and that kind of stuff. And that, again, is, by the way, that's not app data. That's user data. That stuff should go into the libraries, right? There's a picture library for a reason. Users have pictures. They love their pictures. They're personal. They're irreplaceable. Like if I used you, let's say you built a camera app, and I used your camera app to take a picture of my daughter, and then it turned out that for some reason I uninstalled your app, and I lost the picture of my daughter, I would be so displeased with you. But if you put it in my picture library, and I did uninstall you, and maybe I uninstalled you again later, maybe I gave up on you, and then you fixed some bugs, and I decided to use your app again, that's okay. The entire time, those pictures of my daughter were over in the picture library, and I'm okay. We do realize that there may be other scenarios that you would like to do. So for example, you may decide that you have user data, and you want to control like where it lives and how the user experiences it in the cloud and something like that. And for those scenarios, we have the SkyDrive APIs. And I encourage you, if you didn't go to the SkyDrive API sessions, watch them. They should be posted by now, I think. And you should really watch those sessions because they'll talk about advanced scenarios where you can, if the user grants you access to their SkyDrive through like OAuth, you can then directly communicate to the SkyDrive and place user data there. So you can do those kind of things if you want. As I said, that's more advanced, and it puts, now the onus is on you to go and write the network code to talk to it. It's not a lot of code. The SkyDrive team has done a great job with their API surface, but it's more than one line of code. All right, so here are some of the sessions you should go and look at. The 402 is this session here. Okay, so I guess this session is related to itself. Exactly, it's recursively related to itself. The session that is not up here is my Wednesday session. If anyone could grab the Build app and look up and pick some eager beaver, go find me the number for that. That's one you should definitely watch. 475T, thank you. That's the one you should watch. It'll go into a lot of detail about all of these APIs. Yeah, exactly. Somehow it's not related to the session, even though it's the session for this Chalk Talk, but somehow. And this SkyDrive API on 134C, another great talk you should really watch. And so with that, and there's some further reading and docs you'll be able to find. But with that, I really want to open up to questions because I know at least some of the people had gone to the other session, and they probably came here specifically wanting to ask questions. So we have two ways we can do this. They're recording this. So there's a microphone there. If people want to get up and go to the microphone, they can. I think in a room of this size, that's a little bit, a little bit extreme. So instead, what we can do, if you want, is I can go ahead and just repeat the questions into the mic so that they can hear what you said. So does that sound good? Great, let's do this.
So rolling data down to your device, if you're not sending any data up, is that a push or a pull?
So the question is whether the data coming down is a push or a pull. And it's a push. So the way that it works is some other system, some other PC, they're using your app, they change data, it goes up to the cloud, and it, in effectively real time, the other one will get notified, it'll have a connection, it'll get notified, and it will, the data should come down. So when we talk about those like debounce delays of 10 seconds or whatever, that's really on the up. We do have some other limits right now. So one thing we don't want to happen is where like an app is constantly just updating some piece of data, and we're basically sending data up to the cloud like every 10 seconds, nonstop, 24 hours a day. And so there are some, and by the way, one reason is just bandwidth usage and that kind of stuff. Like we're trying to find the balance between, giving a great user experience, but not, just gobbling up user resources because one app seems to just be doing something. And so we have policy in the system that controls both the amount of data, and right now it's at 30K. That may change. Like we we looked at scenarios, we ran some numbers, we figured out 30K was about right, so we shipped it to you right now. And then we'll continue to look at data. We'll get feedback. You should really go, if you have feedback, you can send an email to me, and I'm going to reply very nicely and say forums.dev.windows.com. Right? That's really where you want to go to put your feedback. And I can tell you, if you put your feedback there, like everyone in Windows is reading that. We're looking at it daily, trying to figure out what we did well, what we did not quite so well, what we did really poorly. And so if you have feedback on any of the stuff we're talking about, go there and post it. So when I was talking about policies, there's that 30K policy. There's also some back off where, you know, when you first start updating stuff, it'll go right at the 10-second mark. And then we sort of back off. We sort of say that there's sort of a budget of a certain number of syncs a day that should really come off the user's machine for app data. And we try to budget it so that the user never runs into a situation where they could somehow use up all of their budget in a short period of time, and then nothing syncs for a day. So we sort of like spread the budget out over time. One big reason that you might not realize is it can actually be expensive from a battery standpoint. Turning on like the wireless, whether it's Wi-Fi or 3G, can be expensive from a battery standpoint. We have these really great labs where we take all these machines and we hook up these battery meters to them. And you can watch, if you turn the screen off, get this really low, you turn the screen on, it goes up. You can watch what happens if Wi-Fi turns on, you get a spike. If 3G turns on, you get a spike. And even if we say the bandwidth is okay, and the cloud, the cloud storage scales great, so it can all work. All that you may be doing if you're constantly writing that data is you're just burning the user's battery, and they don't know why. So what we could have said is, make sure you don't do that and write your code so you don't hurt the battery. And you would probably then ask, how do I do that? How do I not hurt the battery? And then we try to tell you what the algorithm is and how to figure it out. Instead of doing that, we just did it ourselves. We just said, you write the line of code. If you keep updating, if you end up, like, say, updating it every 10 seconds, that's okay. We'll make sure that you don't harm the user's battery and you don't use up too much bandwidth, and we'll take care of that for you.
About versioning of applications, if I have to version an application on two machines.
How that works? Sure. Yep. So we actually spent a lot of time and effort on this. Sorry about that. The question is, what's the versioning story if I release a new version of my app, it updates the preferences schema, right? So I used to say, a good example of this is like you ship a mail client, and the first one that you ship, you only support one mail account being configured. And so in your preferences, you just say, or in the settings area, you just write them out, like account name, account password, whatever. That's all you do. You get feedback from your users. Hey, I love your app. I wish that I could configure lots of mail accounts, more than one. I have a work email. I have home email. Like I want to configure all of those. So now you go into your app, you change the code, and now you say, oops, the way that I stored the information isn't very good. So now maybe I'll create a container, like a settings container for each mail account that gets configured. All right, well, now you have to go. You've just changed the schema of your settings that are roaming, which is okay until you think about what happens if I have two machines, and on one machine, I get the new version, and I go and configure like 5 mail accounts. And those settings went up into the cloud. They go over. They come down to this other machine, but I haven't updated the client yet. The code here has no idea that sometime in the future, you're going to change the schema, and so it breaks. So we put in a lot of work to make sure that this doesn't happen. And we do it through versioning. So when you first write your app, you start off effectively we really start you off, I guess, at version 0. But you can right away just say, hey, I'm version 1. I've explicitly set my version. And then you could write out your mail clients any way that you wanted, knowing that in the future, if you decide to change the schema of your settings, all you have to do is, when that app gets launched, you can check and find out what the current schema version is on the system. And right after the upgrade, it would be the old version. You write one function that can convert the schema from the old to the new. So in the mail example, I would create a container and call it whatever the account, first mail account, whatever you're going to call it. And then I would take the data that was sitting there and I'd probably move it into it and delete the old stuff. You write that function, and then all that will happen is you call set version, and you say, here's the function that can go ahead and convert my schema from my old version to my new version. Under the covers, we actually hold off the roaming engine because we wouldn't want, while you're changing, have roaming changing, and then you get some like bizarre mix of both schemas. And once you're done updating the schema, now you're version 2. In the cloud, we still have version 1 and version 2 of the settings. And we roam them independently. So let's say, for example, I'm using your app, and I have 4 PCs. On 2 of the PCs, I have version 1. On 2 of the PCs, I have version 2. This is a pretty weird scenario since most people either update their apps frequently or they don't, but let's just pretend. In that scenario, the settings between the two version 1 PCs will continue to sync. The versions from the version 2 settings will continue to sync. And so we'll never get into a situation where we kind of stick all of your stuff together and potentially break it. Yep. So the question is, can I get notified if new data roams down? And the answer is yes. There is an event, I think it's called roaming data changed, something like that. I should go and look. But anyways, there's an event that you can register for. And what we do is we'll roam the data down from the cloud to this PC, and then we fire the event. And so let's say it's some preference. You can then go, oh, the preferences may have changed, so let me refresh their view and make sure that they have the latest view based on what roamed down from the cloud. You can actually also trigger that yourself. So it's an event that you can trigger yourself if you want to. When you trigger it, you're really just making it easier for yourself. Like, you may have code that handles data change. You can use that same mechanism, and so the code that handles data change doesn't have to care whether it came from roaming or it came from like internal code. What that doesn't do, by the way, is you don't have to do that to tell Windows that the data changed. It knows. Like, we see that data change. You don't need to tell us. It is one line of code. It's just kind of a nice to have for yourself if you want to like have a well-factored code that you put it all in one place. You can then do that. So the question is, I mentioned that as long as you're using their Microsoft account, is that their Live ID, or could it also be Active Directory? As of right now, it's just their Live ID. The roaming feature is on by default. We do have a group policy for enterprises if they want to turn it off. If they said, hey, on all my work PCs, I'd never want that stuff to roam to SkyDrive. Pardon me, sorry. I literally have been talking all week, and my voice is gone. So it's just the Live ID. What was the question? Oh, so the question is the data stored in the user standard profile, or is it stored somewhere else? It's stored in their profile, and it's stored in the local section of their profile. Even your roaming directory and your roaming settings are stored in the local area of the user profile. And the question we usually get is, well, that's weird. Why didn't you stick the roaming stuff in the roaming part of the profile? And then maybe if I'm an enterprise, then I could use roaming profiles to make it all just work. We actually did that initially. That's how we originally wrote the code. And then we stopped and thought for a second. We said, we have all these consistency guarantees. We have these things called composite settings. We tell you how it works. If we let the roaming roaming profile code do the roaming, it doesn't know about any of these rules. And the system not only would behave completely differently, in many cases it would just do the wrong thing because it just copies data. And so we realized that that was a bad idea, and we went and fixed the code, and now we put it all in the local part of the roaming, the local part of the user standard profile. Question is, any of this available in Win32? No. This is a Metro-only feature. We do have a management API that will allow you to get access to a particular app's app data. We really don't expect most developers to use this. It's really targeted towards, let's say that some company wants to build an enterprise version of roaming. They could use these APIs to implement that, right? They could say, okay, I'll have a server that's inside your firewall that's part that your enterprise owns and manages. You turn off the Windows 8 standard sync, and you can use, I'll build you an enterprise sync clients. There isn't one right now. Microsoft, we didn't go off and build an enterprise sync story for Windows 8, but we at least were smart enough to have the APIs if someone else wanted to do it.
Is there a story on the conflict resolution of roaming files?
So the question is there a story on conflict resolution of roaming files? Yes. The way that it works is there's two things. First of all, we will not roam your file while you have a handle open to it, or especially if you have a write handle open to it. I think actually we will roam it if you just have a read handle open to it. But if you get a handle to your file, or in WinRT you actually get a writable stream, which under the covers has a handle to the file. We won't roam because we kind of realize you're probably writing the file right now. If we pick the file up when you're halfway done writing it and put it up into the cloud, all of your other clients would become corrupt. So we wait, and we say we will only roam this once it's complete. Once you're done writing to it, you let go of the handle, and now we can get access to it. Once that happens, then we'll go and we will roam into the cloud. If changes to that file happen on 2 different PCs, we do last writer wins. Now, so what that means is you need to think about when you write to a file about granularity. If you have a whole bunch of data that's like independent, right? So this could be set there, that could be set there. That should be in a different file. And it's okay, you can put lots of files in there if you want to. But that individual file, you will get the latest write from either PCA or PCB, depending upon which had the later timestamp. We tried and looked at like 400 different algorithms to try to be fancy, and we had we have some really, really great engineers, and they were whiteboarding and coming up with all of this stuff. And all we figured out was that you can make it really complicated so that the developer doesn't even understand how it works, and it still doesn't do much better anyway. So we realized that last writer win in a nice, simple algorithm that's easy to understand is really the way to go. And so that's what we did.
What is the granularity of conflict resolution in settings?
So the question, that's a really good question. The question is, what is the granularity of conflict resolution in settings? And the granularity is per setting. So immediately what you're thinking is, well, I have a bunch of settings that are related. And if you're not thinking that, you should be. For that, we have this thing called a composite setting. And a composite setting is it's a single object that you can create. You can just new one up. And then it's a grouping of settings. And now you can set a bunch of settings inside that one. And then you can assign that to a regular setting. And the code would kind of look like this. Let's see if I can. Coding on the fly. Loving it. It would look something like this. I would say group equals new Windows storage dot application data dot. Gotta love that. Oh no, actually, it's called application data composite set, right? Composite. So I'd new this up, and then I can literally just say setting group dot. How does values? No. My setting 1, equals 4. I can set all of those, and then when I'm done, I can just say that, I can assign this to just a regular setting on the app data object, and then those will roam as a unit. And so that's how we sort of keep consistency between a group of settings. Lifetime management was there?
Lifecycle management. So basically, what happens to the old version? Do you delete them yourself?
Oh, okay. So the question is, what do we do about lifecycle management of old versions? And the answer is no. We'd never make you clean it up yourself, because if you didn't, then the user stuff would bloat. We really want to make sure that Windows does as much work as it possibly can on your behalf. So we clean them up automatically. We know what version of an app the user is running on each of their systems that have connected up to sync. And so we can look and say, oh, we better keep version 1 around because he's still using it somewhere. And then over time, once all of the user's systems have been updated with the latest version, then we can retire the old version of the settings automatically. The question is, can an app access other apps' data? Nope. That would not be good. The confidence that we want users to feel is such that we would never want some malicious app to be able to say, hey, I'm going to go look at the Bank of America app's data. I bet there's something really interesting in there. They probably cached something that would be great, like, I don't know, a account number or something. So no, we won't let them look at each other's app data. Each app gets their own app data section. It's created an installation, so we just do it for you. You're welcome. And so when your app gets installed, we go and create these directories automatically. We create these setting containers, and then you can just, the first time your app gets launched, you can just use them. And then when the user's done using your app and they decide to want to install it, which means you obviously wrote a really awful app, and shame on you. But when they uninstall it, we just clean up.
How long does setting live on the cloud? So suppose a user uninstalled all the copies of your software from all of their PCs, and they reinstall them mid-year.
So the question is, what is the lifetime policy for settings if the user uninstalls all of the copies of your app? I don't know. As a matter of fact, I'm not even sure if we've defined that policy yet. You should ask that question on the forums. Please go to the forums, because I guarantee you that the PM that owns that part of the feature will be watching, and he'll see it, and he'll either say, oh, we already thought about this, and John just doesn't know, or they'll say, we don't know. What should it be? I do imagine there will be some retirement policy if the user hasn't used the settings long enough. I just don't know what the date is, the time period is. For most of the stuff, anyway, we're.
I think the key thing there is we won't have it be immediate. So
Sure.
If a user is simply uninstalling an application, to try and fix it or something, and then they reinstall it, and that happens to be the only PC they're on, we're not going to throw away their data in the cloud.
Sure. So I don't know if you heard that, but what my colleague John said. By the way, lots of Johns around. But what John said was that one key point is we don't think it'll be immediate. Like, we won't be like, hey, uninstall, delete it, and then 5 seconds later they reinstall your app and it's gone. Like, we wouldn't want to do that. We just don't know exactly what the length will be. By the way, just whatever the policy is now in the developer preview, just know it's subject to change. Like, you guys are gonna give us feedback. We're gonna go look at the feedback. We're gonna continue to look at the scenarios. Someone may raise a scenario that we hadn't thought of, and we said, oh, this is great for that too, except we made some policy decision that means that it's not great, so we may go and change these things. So So just be aware of that. Don't think that these things are set in stone.
So back to schema differences. What if here's the problem for development? You have different versions of the app on different types of devices, and so it could become annoying that for the user that the schema is different, and they're waiting for us to release the same version of the app and the schema on the other device, and you can't really sync it up.
So the question was, what happens? Not quite.
Right. So phone app, desktop app, different versions of the same app.
Okay. So
I haven't released to the phone system the version.
okay.
Yeah.
So this feature is a Windows 8 feature.
Yeah.
It's not a Windows Phone feature.
So it won't be on the phone at all.
So
no.
as of right now, there's no Windows Phone feature that syncs with this. Yeah. Okay.
I guess just to follow up on that, what if we want to maintain the data in OneNote? Your example on the mail type, so I convert the schema to Go, but I realize that maybe they don't want to update, but they make a change to account 1. Do we have access to update version 1 to version 2 of the app setting?
So if you want to do that, the best way to do it is it is possible to do schema versioning all on your own, right? And so what some actually even internally when people are building apps, most people use the versioning feature. Some people say, oh, actually, I think I kind of want to do more. And so all they do is they say, all right, I'm not gonna touch the old schema, like the old settings, going to leave there. Any stuff that's new for version 2, I'll just put in a different area. The version 2 code knows that it can look both in version 1 and version 2. By the way, the most common way that we've seen that they do this is, I mentioned before that you can create containers, like subcontainers for settings. Well, for directories, we let you create subdirectories. And so what people will do is they'll start their app off, and if they're thinking ahead, they might even create containers and folders named 1.0. And then when the version 2 ships and they decide they want to change something, they just create a new folder, and they sort of manage it themselves. That is the closest thing that I've seen for people trying to do that. In general, we think that the whole, I have multiple PCs and I got different versions on there, it's going to end up being like a really short-term thing. Like most users are either OCD like me, and they're like, hey, there are updates, install. And in every system, there's that little badge will pop up or something, on the tile, and I'm like, hey, I know that means that I have something to do. I'm stressed in life if I don't do my things, so let me go do that really quick, get out of the way, done. And so the time period that I would be in that situation is like minutes. And then some people, like I know, they say, oh, I never do updates. And right now the number's up to like 112. I think every app that I have is probably an update. I never update them because I just don't care. They probably do the same thing on all machines. And so, so we think that in general it's going to be a pretty narrow window. Considering how narrow the window is, we've put a lot of time, effort, and code into making sure that we can do the right thing for it. Oh, so the question is, what kind of encryption is done? We don't encrypt the data for you, as far as I know, unless something's changed. Everything is always subject to change. So if you think that maybe it should be, you could go up there. But Windows ships encryption APIs, and so you should be encrypting your data yourself. The most common data that needs encryption is credentials. We actually have, is it CredVault? We have so many different names. John, is CredVault the right one? I think it's CredVault. If it's something Vault, then I think it's CredVault. Anyways, so there's a feature in the security area of the Windows namespace that will let you actually just store and retrieve credentials, and while they're on disk, they're encrypted. They automatically roam through the cloud for you, still encrypted. And then when they get to the other machine or the other PC, when your code accesses them, you can still get at them. So that's the most common one. If you have other pieces of sensitive data, like let's just say it's an account number, you should just use the crypto APIs that we have. Follow up?
What would you recommend currently for, if I have a Windows 8 Metro style app and I have structured relational storage, something that's completely stored like a single compact database offline. I want that roamed and synced, but so on a per row basis.
That's something that you would have to do. The syncing per row is something you would have to do yourself. We did look at that feature. Oh, sorry. The question was, what happens if I have a relational database and I want syncing to happen at a per row level? We don't have that feature in Windows 8. We looked at it, and it turns out that those nice simple policies don't really apply to databases. Like the relational databases have all kinds of, or different apps have all kinds of different requirements around consistency that they don't express in the SQL schema. And so if we just did per row, that might work great for your app, and other apps may blow up. And so it's something that we couldn't find a nice simple way to do it that developers could understand, that we could implement, stabilize, and ship on time. So we're not doing it right now. Yeah, it's just, so under the covers, there's this thing called an app container, which is just a way for us to group all the processes for your app, and it has an identity. Yeah, actually, there is a job. But as part of that job, there's also a SID in the token, and that SID is there just to identify your app. So we know not just that it's John Sheehan running, but it's also John Sheehan's version of, restaurant guide that's running. And when you go to access data, that information is used as a secondary check to make sure that you're only accessing your app data. If you try to go and access someone else's app data through, we don't even give you any API in the Metro SDK to do that. But if you somehow figured out a way to do that, it just would fail. Oh, you don't even have to impersonate. Like if you're a system service or if you're a full trust desktop app, you're what we call full trust. You can act as the user. And so one thing we don't try to do is say, hey, there's these like full trust, really powerful things. Let's try to protect them from these like lower, lower privileged apps. And so if you're a system service, you can just get at it. They're files on disk. You can just go get them. So the question is, what's the granularity of a sync job? If I set lots of settings, would I get lots of sync jobs? No, you wouldn't. One of the reasons we have the debounce period is because you write the first setting, and very often you're going to write another one right behind that, another one right behind that, and another one right behind that. And we specifically didn't want to start creating lots of jobs, because each job there's going to be some CPU overhead, which equals battery, which equals spending resources. And there's going to be some network traffic associated with it, same thing. And so we have these sort of like periods in there to give the code a chance to do a bunch of updates. Excuse me. The job happens, and then we gather up all the updates that happened, either for settings or for files during that time period. And that becomes one sync job.
So how do you handle making sure that installing on a second system doesn't override, like the default settings doesn't override the already existing settings you install?
Good point.
Those are new settings.
Right. That's a good question. So the question is, how do we make sure that if I install cleanly, I don't end up with the defaults blowing away the stuff that I had in the cloud? We have a couple of things there. The first one is that when your app gets installed, we immediately, before your app even launches, we go and fetch the roaming settings and get them on disk. That's the first thing that we do. And if you're installing the app, then you have network connectivity. And if you have network connectivity, then we're going to get your settings. Additionally, when the app starts up, excuse me, there is some extra logic in there when we do a sync to say, you know, have we synced roaming stuff here before or not, right? Has the app just come up clean? And if it just come up clean, so let's say, for example, the ordering was, I installed the app, that worked, I lost network connectivity, so we couldn't get the sync stuff down, even though we kind of do it all together. But it could happen, and we thought about this. We have some really smart engineers who are really passionate about this stuff. And then, so you lose network connectivity, so we can't get the settings. And then I launch the app, and so now it comes up clean, and I'm like, whoa, what happened? When you do get network connectivity and the roaming data comes down, it will actually say, oh, this guy started up clean, and we never got to roam it, and so it'll actually apply the settings, and you'll get a notification. Okay, so the question is the 30K limit, how is it enforced? It's enforced as part of the syncing operation. So you actually can write more than 30K of data into that section. We're not going to, like, in the file, we didn't, like, go and change the file system, which, again, thank you, you're welcome. I mean, like, we really don't want to go into the file system and start making all these kind of changes, and so we said, no, we want something simple that's robust and works. And so you could potentially, for a period of time, have more than 30K. If you do, it's just not going to roam. The roaming engine will just say, I can roam 30K, and there's a lot more there, and so I'm not going to do it. We do have APIs where you can query, because, by the way, please don't go back and start writing your first app and start hard coding to 30K. Like, that's what it is today. And actually, over time, we may change the policy in the cloud to say, oh, now it's 50K, or, you know, now it's 35K, or whatever, based on feedback. And that change could happen even after we ship. So we give you an API where you can query for the quota and also find out how much of it you've used. So that way you don't go over. In general, we usually have these conversations with all the developers internally, and they're really worried about getting really close to it and everything. But by the time they actually figure out what settings they're going to roam, and they figure out how they're going to roam the experience, they're usually well under it, and it becomes one of those things where they stressed out for a while and thought they were going to have to, like, do lots of hard thinking, and then it just turned out being a no-op.
Is there any story that you follow for the phone or IPTV and other devices and you want to get those types of settings down first?
The question is, can I talk about the phone and IPTV, did you say? And getting these settings down onto those. Not really. I do know that the live team has looked at the SkyDrive APIs. I don't know what exactly they've decided yet. And actually, I don't even know if they've made a decision yet. So I would go to that, I'd go watch that SkyDrive talk first, and then I would post on the forums if it doesn't answer the question. There has been talk about, hey, maybe we should have APIs available for other platforms to kind of interact with this data, which sounds good, but then you start getting into, oh, great, so now we're doing this syncing. The danger is we have all this logic, and we put all of this time and effort into making sure that the data is consistent, that you don't lose data, that we have different versions, and, like, we did a lot of work. Like, there's lots of engineers, you know, on the Windows team that have poured a lot of time, effort, and sweat into making these things work just right. And the danger is, if now we just let, you know, you just go write your own version of that code on some other platform, and then all of a sudden your users start getting corruption. So I don't know what they've finally decided, but I would, like I said, I'd first watch their talk, the recording of their talk, and then I would post on the forum. The question is, does the implementation of the cloud service have any commonality with the notification service? I'm not sure. Like, I really don't know. I mean, I know that we have lots and lots of servers in the cloud. We have lots of storage in the cloud. But I don't know if under the covers, if they're sharing any of that infrastructure. The question is, what is the on-disk representation of settings? The answer is it's a single file. Yeah, so as I said, you can. We have the APIs for reading the settings from like a desktop app. As of right now, in the build that you have, there's no like UI for going and looking at settings. We're aware that that would be great. I don't know if we'll actually get to building one. I hope that we do. If we don't, some enterprising developer, I'm looking at you, could go and build one if they wanted to. But definitely, please, whatever you do, do not try to go and like figure out the format and then go try to mess with it. Like just use the public APIs that we have. We put lots of effort into making sure that we provided all the services for you so that people wouldn't feel the need to go and mess with files. The question is it using queuing for WCF? My understanding of the implementation is it's a proprietary implementation that we have under the covers for our syncing and talking to the cloud, and it's. But again, I would ask on the forums, but it's one of those things that I'm not sure how that would really affect your apps. No. Just curious? Yeah. As far as I know, they don't use WCF. No. I saw two hands go up and then come down. So the question is, what happens to your app if the administrator goes and flips off the roaming setting? The answer is, your app won't notice, other than the user experience just won't roam. So one of the things about the roaming section is it's stored locally. Like, you don't need network connectivity. I could go to sub-Saharan Africa with your app and use it for a year and never connect to the internet, and it'll work just fine. It's just that none of my other PCs would ever get any of the changes that I made on that one. And we were very careful about that, because that is another thing that goes into all the decisions that we make. We want to make sure that we make your life as easy as possible. The people on the team that did this work, or teams actually, there's multiple teams that have all worked together to make this happen, are all passionate about that. And we've been through tons and tons of revisions of these APIs and how to do it. I can tell you right now, the API shape and the way it's so easy to just go in and just type a line of code and it just works. We actually checked in and made it to mainline with like 4 or 5 different API shapes before we got to this one. And it was painful for the teams that worked on it, because they were like, oh, I thought it was done. No, we have a better idea. Did it again. Went through the API review board. Said, oh, why don't we shape it like this? That would be even better. Did it again. And we went through and again until we said, we got it right. This is right. This is what we really envision in our head, even if we couldn't see it.
With the forums, be the best place to find out about the dependencies. So what can an IT administrator do to screw up roaming profiles? What firewall port could they block, or what do we need to open to allow it to work?
Oh, okay. So the question was, is the forums the best place to find out, like if you're an IT administrator and you want to either block it or not block it? Yeah, the forums right now would be great. I mean, eventually this should be documented. By the way, how am I doing on time? I'm over. Okay, all right. What I'll do is turn off the mic. We can go outside and keep asking me questions, and eventually my voice will stop, and then I give up.